Welcome to qnawire.
Okay, question 43 is an interesting one because it says that Marsha is pushing down and to the right on a 12-kilogram box at an angle of 30 degrees below horizontal. The box slides at a constant velocity across a carpet whose coefficient of kinetic friction with the box is 0.7. And then the question simply asks us to determine three physical quantities using this information, one of which is a kinematics quantity. So we'll draw out the scenario. We have a box with a mass of 12 kilograms. And Marsha is pushing down and to the right with an angle of 30 degrees with a force F. The box is on a rough carpet, so there is a force of friction that is opposing motion horizontally, with a coefficient of friction that is recorded as 0.7. Of course, this is kinetic friction. Lastly, we have the normal reaction force preventing us from sinking into the carpet, and of course the weight of the box. So let's see what we can get out of this. Well, first of all, we know that we can take a few equations that will effectively work for us. For example, the force of friction is going to be equal to the kinetic coefficient of friction multiplied by the normal reaction force. And hence we can determine an equation, which is that if we're sliding at a constant velocity, then the force with which we're pushing, force cos 30, is going to be equal to 0.7 multiplied by the normal reaction force. What else can we say? Well, we can also draw up the conclusion that vertically, so this would be horizontally, and this is vertically, the weight of the box added to the force which we're pushing down with, which is F sine 30, this is going to be, subtract from that, n is equal to 0. So the downward forces are balanced by the upwards forces, and hence we are not sinking into a carpet. What we can do here is pretty simply to rearrange both of these equations, 1 and 2, to be in terms of n. That is, very quickly, we say that F cosine 30 over 0.7 is equal to n. And we can also say that 12g plus F sine 30 is equal to n. And what does this mean for us? Well, we can set these two equations equal to each other. And hence we get F cosine 30 over 0.7 is equal to 12g plus F sine 30. And what does this mean? Well, we take over the F sine 30 to the left-hand side and factorize out the F, leaving us with F in brackets cosine 30 over 0.7 minus sine 30. And this is going to be equal to 12g. And so finally, the force that we're pushing with is equal to 12g over all of this stuff, cosine 30 itself over 0.7, subtract from that the sine of 30. It's one of the ways that we can solve a simultaneous equation. Anyway, placing this into a calculator, we scroll down the page a little bit here. Placing this into a calculator, we determine that this force is equal to 160 newtons. So this is one quantity we can determine. Other quantities, for example, the normal reaction force, can be drawn pretty simply from the equations that we've already got. For example, we take equation 2 here and say that we know that 12g added to F sine 30 is equal to N. And we know F is 160 newtons. Hence 12G added to 160 multiplied by sine 30 is going to equal N. And we put this into a calculator to determine that N is equal to 197.6 newtons. Anything else? Of course, we'll try and get as much out of this as possible. We can say that the force of friction is simply equal to the force which we're pushing with multiplied by the cosine of 30. And that's 160 cosine 30, which once again in a calculator gives us 138.6 newtons. So we've got a lot of quantities here. There are a couple of other things that we should note, but we are neither sinking into the carpet nor floating away from it. And so there is no motion in the vertical direction, and hence the acceleration in vertical is just by inspection 0. Likewise, we are traveling at a constant velocity, even though we have forces involved, they are balanced. So the force that we're pushing with is opposed by friction, and hence no acceleration in the horizontal direction either. And so there's not an awful lot we can determine beyond this. Our kinematics quantities, I suppose, are our acceleration in x or y, but without knowing how fast the box is actually moving, we just know that it's traveling at a constant velocity, and hence we know that that constant velocity is maintained, so its initial velocity is equal to its final velocity. We could also determine distance if we knew how long it was moving for and how fast it was moving. But as it stands, these are the quantities you can take from this question. So you have the normal reaction force, the force of friction, and the force that you're pushing with. Of course, you could also determine the weight, which is simply 12 times g. I don't see why we can't just do that very quickly now. So we can say that the weight of the box is equal to 12g, which is 12 times 9.8, which is 117.6. And that's it for questions.